need to pay attention. So this thing here is called, when you have a piece of pie, this is called a sector, okay? And a sector is basically just a piece of the circle. So if, what? It's an O, S-C-C-T-O-R, okay? So if you have a sector, and say they tell you that this is a 90, let's not make it 80, let's make it 100 degrees over here, okay? And say they say that this is 6. The formula for finding the area of a sector, and you should write this on your conjecture sheet, is just n over 360 times pi r squared.
What does n represent?
N represents
6.
The central angle. Okay?
Maybe not.
Okay? The central angle. So it's really just what fraction of the circle do you have, right? So in this case, it would be 100 3/60ths of pi times 6 squared, right? And a lot of times things cancel out, which is nice. This can reduce to what? What could 100 3/60ths reduce to?
Take away
36.
10 to 36.
5/13.
Well, let's not reduce it that far. Because what's 6 squared?
36.
36. I could reduce this down further, but what is nice about this is then I could just cancel out this 36 with that 36, and I get 10 pi, which is about equal to 314.14159, right? So,
Yeah, sure.
So
31 point. Yeah, is it 30? Let's just keep it at 114.
about, oh yeah, you're right, 31.4, sorry. 31.4, whatever the units happen to be, okay? So square units, whatever those are, okay? And that's called a sector, okay? And then we have,
Wait, what happens if it doesn't simplify?
what happens if it doesn't simplify? Then you just leave it as what it is. And you take it down as much as you can, okay? Take notes. Okay? So then we have something called a segment of a circle. And a segment of a circle is what you get if you take a circle and then you make a sector like that and like that, and then you cut that over here like this, okay? And then this thing here, this piece right here, is called a segment of a circle. So this is called a segment. And if this is N and this is R, and can anyone think of a way? Just think of the picture. How would I have to figure out? How can I figure out how to find that segment? Yes, Sam.
You can find the sector,
Right.
and then you can subtract the area.
Exactly. Okay. So the sector in the big picture, it's equal to the area of the sector, right?
Is it a 2?
Sector is what a 2. This?
I thought the n was a second.
No, that's just an int. Okay. It's area of the sector minus the area of the little triangle inside there, right? Because if I take this sector and I subtract out that piece, what I'm left with is the segment. So let's say, for instance, that all I have is, let's say that I have this, okay? That this piece is 6. They tell me this is a 90-degree angle right there. And they say, find the area. Times area. Okay? Well, what's the area of the sector?
Well, 6.
What's N? 90. So N would be 90, right? Because this is a 90-degree angle right there. So it'd be 93/60ths of pi times, what's our? 6 squared
goes in
minus,
four times. I mean,
what's the area of this triangle?
18.
8, very good. Okay?
How'd you get
Because how do we get 18? Because in a right triangle, this could be the base and this could be the height, right? So in a right triangle, in any other type of triangle, you'd have to find the height of this triangle. But since this is a right triangle, you can multiply the two sides together, right? And divide by 2. So that'd be 6 times 6 divided by 2. And then your answer, this reduces to what over here?
That reduces to 4 over...
1 over 4 times 36 minus 18. Now this reduces to 9 pi. Everyone see where I got 9 pi? Okay, now I get 4 goes into 36 9 times.
I got you.
Minus 18. And you leave it like this. If they say find the exact area, then you leave it like that as the exact area. So whatever the units have to be. Square units, square inches, or squinches, or whatever you want to call it. But if this were inches, then it'd be squinches, right? Square inches. Yeah. But that's exactly an area. And you can't really combine these unless you plug it into a calculator to combine. Yes, ma'am? If it wasn't a right triangle, then you'd have to like find out the height. Maybe they'll tell you this is 5, and you need to know the base, right? And then you'd have to know some other things.
Would they give you that all though?
Yeah.
Yeah.
Okay. Yes, Chris.
We're done with listening.
What?
Are we done? We're done with listening.
Done with what?
Still right? The lesson. Are you done?
No, we're not done.
Oh, okay.
Okay. So we are moving on to the next thing, which has to do with the area of something called an annulus. Okay. Annulus is what you get when you put a circle inside a circle like that, and you get the donut. This donut right there. The outside piece, right? That is called, the green part is called annulus, okay? Is that how you spell it? I think so. Okay, no, that's right. And so if you have 2 radii in the annulus, so sometimes they call this big R, the big radius from inside to the outside, and they call the little radius little r. Okay. Who can tell me a formula to find the annulus of a circle, or not? You got that, Jen?
R1 minus... Oh.
Not big R minus little r.
That's not it.
It's pi times big R squared
Thank you.
minus pi times little r squared.
Yes, exactly. So the area of that thing is going to be, who said that? Very good, Harry. Pi big R squared minus pi little r squared. Good? And so, then say for instance they give you that this is, just for fun, let's say they tell you this piece from here to here is 2. Let's continue, please. So if this little piece is 2 here, okay, and let's say that this radius is 4, this piece, I mean, from here to here is 2. How would I find the area of that annulus? What's the big radius? 6, okay? Because from here to here is 4, so 2 more. So you get pi 6 squared minus pi 4 squared, which is, watch how I do the math, is 36 pi minus 16 pi. How many pi's do I have altogether?
20 left.
20 pi whatever the units are, square units, units. Okay? And that's how you do that. Now, I do want to do one where you go backwards, okay? Because these could be a little tricky. Say, you got that?
No, we need to.
Okay. You need what? Let's move on.
Yeah. No, I need a little more time.
Okay. So, the next thing that we're going to do is just talk about a problem in which, say we are going backwards. Okay. So say you know that you know this piece, you know this piece, and you know that this is 6. I don't know why I called it 6, but I didn't. And we call this N. And they tell you that the area of the shaded part right here, okay, that the area is 14 pi. And they say find N. Okay? So this is some of you, Sarah, would you do me a favor and put your phone away? Well, put it away. Gonna look up here. Okay. Unless you want to tell me how to do this one. Can you tell me how to do it?
Wait. I think I know.
How? No, without cheating, by looking up here and using your brain.
So would it be that you go 14 divided by 360? What you really want to do, like a lot of you guys are lazy, and all you want to do is plug things into a calculator, okay? And try to find the answer that way. But when you get to more complicated math and you're solving for a variable, you got to set up an equation and you got to do algebra, okay? Go ahead, Isabel.
So it would be n over 360
Right.
times pi 6.
Right, times pi 6 squared equals 14 pi. That's the way you want to set it up. Because then you have to say, you don't have to say, oh, I divide by this and multiply by that. You want to set up an equation, do algebra. And most of you guys, I'm assuming, took algebra because you are in this class, right? And so what you can do right away is cancel out a pi from both sides. See that? Divide away a pi. And so you get n over 360 times 36 equals 14. Right? This fraction reduces like we did before. What does that reduce to? N over 10 equals 14. Now what? Divide?
Multiply.
Multiply by 10. Okay? And I get n equals 140 degrees. Okay? So that's why you really want to do this algebraically. You don't want to say, well, I think I multiply by this, divide by that, and do that, and so on. Okay? You got to do the steps. Right? Your homework, yeah, now after I write down the homework, page 439, 1 through 10, and 11 through 17 on. Okay? Okay, and that is your homework. And remember, oh look, 14 minutes exactly.